Okay, so today we have to discuss about the important topics of the thermodynamics and the equilibrium. Okay, we'll combinedly will take the topics of the chapter and along with we'll do some past year questions and some repeated questions which can be easily asked in the exams. Okay, so the first topic I'm covering that Lee-Chatelier principle. Lee-Chatelier principle. So that Lee-Chatelier principle says that if there is any kind of change in the equilibrium itself adjusts in such a way that it will counteract that particular change. So if there is a increase in the concentration on either of the side, it will change itself. If there will be a change in pressure, if there will be a change in temperature, the equilibrium will adjust itself in such a way that the change will be counteract. Okay, so let's discuss some effect. That first effect I'm saying, that is effect of pressure. So this we can go for example like N2 plus 3H2 is in equilibrium with 2NH3. Okay, all are present in the gaseous phase and the delta H value is equals to minus 92 kilojoule. Okay, it's just a hypothetical example that whatever I'm taking. But what you have to remember, if the value of delta H is in negative, if the value is in negative, it means we are talking about exothermic reaction. And if the value of delta H is positive, it means that we are talking about endothermic reaction. Okay, so in this particular reaction, nitrogen is combining with the hydrogen to form the ammonia gas. So effect of pressure, if I'll say, if the one volume of N2 is combining with the 3 volume, it forms 2 volume of NH3. So there is a decrease in the reaction from 4 volume to the 3 plus 1 is equals to 4 and there is 2. So there is a change in decrease in the volume. So according to the Lee-Chatelier principle, if increase in the pressure favor the direction where there is decrease in volume. So it means if there is a decrease in volume, it will start moving towards the direction where the volume is less. So it means the more product will form. The forward reaction will take place. Same way, if I talk about the effect of temperature, effect of temperature. See, in effect of pressure, you have to remember where the volume is less, the equilibrium will shift in that particular direction. It means it will favor, in this particular case, it will favor the forward reaction. While if the product concentration is increasing, just imagine the right side it is 4 volume and the left side it is 2 volume. So it means the product concentration is more and the reactant concentration is less. So at that particular time, what you will do, the reaction will shift in such a way that it will tend to decrease the volume on the right hand side and the left hand side will start increasing. Okay, so this is the effect of pressure. In case of temperature, low temperature favor forward direction. Low temperature favors the forward direction just because it's an exothermic reaction. Okay, so optimum temperature, see this reaction is known as Haber's process. Just remember, sometime it can be asked like which process it is known as. This is called Haber's process. So in this Haber's process, the optimum temperature you have to remember that is 725 Kelvin to 775 Kelvin. Okay, and here we have catalyst also. So catalyst start catalyst only alter the rate of reaction. Okay, it just don't change the reaction. It helps the equilibrium to establish earlier. So this is all about the Lee-Chatelier principle. You have to remember effect of pressure and effect of temperature. And most probably there is a possibility that you will get the question from only the Haber's process. So just remember this is important. Okay. Sometimes there is a relation of Kp and Kc. So Kp and Kc relation is also important. That is Kp equals to Kc RT bar delta N. This is a relation. Okay, and how delta N is calculated, that is C plus D minus A plus B. And what is C plus D and A minus B? A plus B, that is the stoichiometric constant of the reactant and the product. Okay, so for example, this reaction is given like N2 plus 3H2. This is an equilibrium with 2 molecule of NH3. Okay, And now the question is asked like you have to drive the relation for the Kp and Kc for this particular reaction. So just first calculate the value of delta n. Delta n is equals to number of moles of product minus number of moles of reactant. That is product and that is reactant. Same thing. So Np minus Nr. So on the right hand side we have 2 minus on the left hand side we have 2 1 H2n, oh sorry, 3 H2n 1 N2. Those reactant which do not have any stoichiometric constant we consider it as 1. So 1 plus C is equals to 4. So 2 minus 4 that is equals to minus 2. So here the value of delta n is minus 2. So in this particular case it will be like Kp equals to Kc RT ki power minus 2. So in this case you have to remember that Kp will be less than the Kc. So you have to do like this. So question can be asked like this. Okay. Next important topic is types of system. Types of system in the thermodynamics we have discussed that three types of systems are there. First one is the open system, second one is the closed system, third one is the isolated system. Okay, so in case of open system we can see heat is also exchanged, the matter is also exchanged. Okay, for example I have a cup of tea and see the matter can exchange outside and the heat can also exchange outside, so it's a sort of open system. While in the case of closed system, just do one thing. We have the same cup of tea, but we have a lid over here. Okay. So in this case, the matter cannot be exchanged while the heat can exchange. So that is a closed system. What if I talk about isolated system? In isolated system, we have some sort of thermostat condition in which the heat as well as the matter they both cannot exchange. That is called isolated system. So on the like 1 marks question, 2 marks question, you can get these kind of questions. Okay, so combining the I'm taking the board topic of equilibrium and thermodynamics. Next is Hess law. Hess law of constant heat summation. Okay, name is quite big, but the and for us to understand this topic, it is very easy. See, if A gives out B and B gives out C and C gives out D. Okay, change in enthalpy here is delta H1, here delta H2 and delta H3. And another process like A is directly forming the D, that is delta H. So according to the Hess law, that delta H is equals to delta H1 plus delta H2 plus delta H3. It means whether the reaction occur in the single step or in the multiple step, the heat summation, the amount of heat, amount of the enthalpy will remain same. For example, we can make like uh, the main reaction is C plus O2 gives out CO2. In this case, the delta H value is minus 393.5 kilojoule. Okay, so minus it means exothermic again. This is a single step reaction. But if I do this particular reaction in the multiple step like C plus half O2, it gives out CO2. It gives out CO, sorry. It gives out CO and the delta H1 is equals to minus 110.5 kilojoule. And this CO plus half O2 gives out CO2 again. Delta H2 is equals to minus 283.02 kilojoule. So approximately if I'll add these two values, that is equal to that one. So the here delta H is equals to delta H1 plus delta H2. So it means whether the reaction occur in the single step or the multiple step, the heat change will remain the same. This is what? This is Hess law. So for the exam point of view, it is quite important. Just don't forget to do the questions according to this particular method. Okay, so one more thing, important topic if you are discussing, that is extensive and intensive properties. Basic definition based question can be asked from this topic. Okay, so See, we have some macroscopic properties like mass, pressure, temperature, surface tension, viscosity. Okay, these type of properties are divided into two categories, that is extensive and intensive. If I talk about the extensive one are those properties whose magnitude, whose magnitude depends on the quantity of matter, on the quantity of matter. If the magnitude is dependent upon the quantity of matter, it means we are talking about the extensive property. For example, we can say like mass, volume, heat capacity, we have entropy, we have heat content. What else? We have Gibbs free energy. These are all intensive property, etc. But extensive property, sorry. If I talk about the intensive property, just opposite to the extensive, that is which do not depend, which do not depends on the matter present, on the quantity of matter, sorry, on the quantity of matter, quantity of matter. So it's very easy. Example, if we want to discuss, that is surface tension. They don't depend upon the matter. Viscosity. We have density. We have a specific heat, refractive index. We have boiling point. We have freezing point. We have vapor pressure, etc. These are called extensive property. So this is also important for the exam point of view. Okay. And laws, first law, second law, third law of thermodynamics, this statement. So I'm not going to explain all the laws, but I'm writing for the exam point of view, like first law, law of conservation of energy, I think you know. Second law is second law of thermodynamics. And third law also of thermodynamics. First law, that is law of conservation of energy, that energy can neither be created nor be destroyed, but can change from one form to another. Second law will say it totally depend upon the entropy change, that it was talking about the entropy, or you can say spontaneity. Okay, spontaneous, non-spontaneous reaction. Spontaneous reactions are those reactions which either itself occur or by initiation it can occur, while non-spontaneous reaction are those reactions which talks about the which cannot be initiate or which cannot occur by its own. That's the no, like that is the topic you have to cover under the second law of thermodynamics. Okay, third law of thermodynamics states that the see, this is important, the statement can be asked like the entropy of perfectly crystalline substance is zero, but the condition is at the absolute zero of temperature, that is minus 273 degrees Celsius. Okay, so it means if the entropy of the perfectly crystalline solid substance will be zero if the temperature will be zero, absolute zero. Okay, that is equals to minus 273 degrees Celsius. So you can say like S limit temperature tends to zero, zero. Okay, that is quite important, so just don't leave this topic. Next, let's discuss about some type of acid base concept. So acid base concept, if I'll say, first concept we'll talk about the Arrhenius, second we'll talk about the Bronsted and Lowry concept, third we will discuss about the Lewis concept. Okay, Arrhenius concept. See, H positive donate when in aqueous medium, then it is a acid. OH negative donate or furnish, you can write in aqueous medium, then it is called base. Okay, Bronsted-Lowry, proton donor, proton acceptor. Those compounds which donate the proton, they are called acids. Those compounds which accept the proton, they are called base, like NH4 positive. Okay. Lewis concept, electron acceptor and electron donor. Electron acceptor species are called acids. Electron donator are called bases. So these are some basic things you have to remember. Apart from the Bronsted-Lowry concept and this Lewis concept, we have one topic in the small topic in that Bronsted-Lowry concept, which is also important. That is conjugate acid and conjugate base. Conjugate acid and conjugate base. So for this conjugate acid and conjugate base, what you have to remember is like, see, just add one H, it means it will form acid. Just remove one H, it will form conjugate base. Okay, adding H positive, conjugate acid, removing H positive, conjugate base. So it's very easy. For example, I'm saying like OH negative. Okay, OH negative, I'm adding H positive. Okay, it will form H2. Now this is, according to it, it is accepting the H positive, so it will becoming the acid. Okay, or like HCO3, HCO3, H2CO3, like HCO3. If I add one H, that is H2CO3. So it's a carbonic acid. So just remember, adding H, conjugate acid, removing H, conjugate base. So H negative is a conjugate base, and H2 that is in case considered as conjugate acids. So next topic we'll take about the Lewis concept we have discussed. Okay, so we don't have to go it more deep. Hess law, just remember, just don't leave the Hess law. That is important. Then first law of thermodynamics we have discussed. Second law of thermodynamics we have discussed. Again, it's quite important. Conjugate acid, conjugate base. One more example we can do, like for example, we have HSO4 negative and we have H2O. Okay, we have to make the conjugate acid and conjugate base also. So if I'll add H positive, it will be H2SO4. If I'll remove one more H, see here H positive, here minus H. So it will be SO4 2 negative. H2O, if I'll add H positive, it will be H3O positive. If I remove one H, it will be OH negative. So these two are conjugate bases. These two are conjugate acids. So just remember, just add H positive, it will convert into the acid. Just remove H positive, it will convert into the base. So not a big deal, just remember. Okay, third law we have discussed, that is, okay, sometime one more definition is also important, that is entropy. What is entropy? Entropy is the measure of randomness. Measure of randomness. What are this? Or you can say disorderedness of a system. Whatever the system is having the randomness. For example, gas. If I talk about the gas, the particles of the gases are quite random. So they have maximum entropy. If I talk about the that solids, solids have the minimum entropy. Why? Just because the particles are not in random motions. They are stuck on that same position. The bond between those solids are quite good. So they don't move. So it means the randomness is less. So the entropy will be again less. Okay, what is pH? That pH is the negative logarithm of hydrogen ion concentration. See, here in the chemistry, the square bracket represents the concentration, molar concentration. So if someone asks what is pH, you can just convert into the definition form that is considered as negative logarithm of hydrogen ion concentration. That is called pH. Formula is written over here. Question, basic question we can do, like if you need to calculate the pH. So for the calculate pH of 0.001 mHCl, So this is the question. So M means molar concentration, that represents the bracket. So what you have to do, that pH is equals to negative log base 10 of H positive. This is base 10 log. Okay. H positive, this was the formula. So minus log base 10, 0.001. If I'll change it, it will be minus log 10 ki power minus 3. And we know log m ki power n is equals to n log m. This is the formula. So we can write like minus will come in the front, minus 3. So minus minus plus. So it will be 3 log 10, which is if log 10 value is 1. So it will be 3. The pH of the compound will be 3. So basic question can be asked. Just you have to remember the how to calculate the log. We have already discussed earlier. One more example let's discuss on the pH. Like question is 0.01 MHCl. Calculate pH. So here in this condition, pH again is equals to negative logarithm of hydrogen ion concentration, which is equals to negative log of 0.01, which is equals to negative log of 10 ki power minus, okay, 0.1 minus 2. So it will be 2. Okay. So just don't leave such kind of questions in the exam just because you don't remember the formula sometimes. So it's easy. So don't forget to do these questions. These are all important topic what I'm doing right now. Just 1 second. Okay. Law of mass action in equilibrium. That is also important. Law of mass action. See, um, consider there is a reaction A plus B is in equilibrium with C plus D. Okay. So according to the law of mass action, at any instant, the rate of chemical reaction at a given temperature is directly proportional to the product of what? Product of active masses of the reactant at the instant. For example, here rate will be directly proportional to the molar concentration of A into molar concentration of B. So this is rate law expression. And for the definition, I'm repeating once again, like at any instant, you have to mention the word instant. At any instant, the rate of chemical reaction at a given temperature is directly proportional to the product. Product of what? Product of these reactant, product of the concentration of the active masses of the reactant at that instant. That is called law of mass action. So just remember the definition, then it will be easy. And remember one more thing, if the delta H is negative, it means we are talking about exothermic reaction. If delta H is positive, it means we are talking about the endothermic reactions. Okay. Entropy we have discussed, that is, it is a measure of the randomness. Okay, if the question is asked like we have done entropy here now. So for the system entropy, delta S is equals to S2 minus S1. S2 will be the product entropy and S1 will be the reactant entropy. So just subtract the product entropy, reactant entropy from the product entropy. That will be equals to the change in entropy of the system. Okay. So entropy based numerical can also be asked in the question paper. So just don't leave it. Okay. One more pH question. pH is equals to 1.0 into 10 to the power minus 8 m HCl. Calculate pH. Sorry. Calculate pH of. Question is like this. So let's calculate. That is, so here in this question, there's something more is given, like just make some question like something different from that last one. That is, cal calculate the pH of 1.0 into 10 to the power minus 8 m solution of HCl. Now, if I'm talking about the solution, it means the solution contain HCl and water. And you know that water also contain the H positive ion. So we know from the ionic product of water, the value of H positive in water is 10 ki power minus 7. Okay, m. And for HCl we have given like 10 ki power minus 8. H positive for in HCl is equals to 10 ki power minus 8. So total it will be around 10 ki power minus 8 plus 10 ki power minus 7, which is equals to, okay, let's, we can do like, instead of the total H positive concentration we can like add. So just because it's plus in the middle, so it will be 10 ki power, you can write 10 ki power minus 8 plus 10 ki power minus 7 minus, that will be equals to 10 ki, total value must be equals to 10 ki power minus minus 7 m. You have to take like this, only the concentration in the water also, just because we have value this one also. So or already you can do one thing, like instead of this, just take the value like log minus log p, sorry, pH is equals to minus log of this 10 ki power minus 8 plus 10 ki power minus 7. Just calculate this value and done. Formula you have log m plus n is equals to log m upon n. Okay, so whatever the answer will be, it will be easily calculated. So answer is approximately 6.995. So just use this formula and you can calculate. Okay, don't give a long time in such numericals. One derivation which is most important, that is derivation, that is Cp minus Cv equals to R. This is the derivation. So first of all, for understanding this, one term is heat capacity. Okay, what is heat capacity? See, the amount of heat required to raise the temperature of the system by 1 degree. You have to raise the temperature of the system by 1 degree, and whatever the amount of heat is absorbed or involved, whatever it is required, that is called heat capacity. Okay, and we denote heat capacity by C. So we have uh, some derivation on the basis of this. So let's start. That is, we know that heat absorbed by the system is denoted by Q. Q is the heat absorbed, and there we are changing temperature when the heat is absorbed, that is equals to dt. So we can write like C is equals to Q upon dt. This is the heat capacity. Okay, so we have two things here. First is heat capacity at constant volume. Second thing is heat capacity at constant pressure. So we have two type of heat capacity. So first we'll calculate the heat capacity at constant volume. So we know from the first law of thermodynamics, first law of thermodynamics, we know that Q is equals to dE plus W. Okay, and W is equals to PV. So instead of W we can write like Q is equals to dE plus PdV, just because there is a change in volume. Okay, PdV. So in just put the value of Q in this equation. This is equation number 1. So it will be C is equals to dE plus P dot dV divided by dt. Okay, so if we are saying at constant volume, we are calculating the heat capacity at constant volume. So dV will be equals to 0. So here we'll write CV is equals to dE upon dt at constant volume. This is called heat capacity at constant volume. Okay, definition, we can say like heat capacity of the system at constant volume is defined as the rate of change of internal energy. Here E is internal energy with temperature at constant volume. Okay, now calculate the Cp. Now let's calculate the Cp. Cp is equals to Qp upon dt. Again, same. If we had Q over dt, so Q over dt, we just calculate the value of Q and we'll put in this particular equation. So, uh, which is equals to here dE over dt at constant P. I'm just, the above equation, this equation, I'm just separating. It will be P dV over dt. Just take P outside, just because we are talking about that constant pressure. P dV over dt. And we know that H is equals to E plus PV. Okay. So if I differentiate this equation, differentiate above equation with respect to temperature at constant pressure. So this equation will be dH over dt is equals to dE over dt at constant pressure plus dV over dt at constant pressure. So just see this equation, consider this equation number A, consider this as equation number B. This equation, A equation and B equation, the right hand side is same. So we can write like Cp is equals to dH over dt at constant pressure. So now we got the value of Cp and Cv. So what you will do now, now see Cp value you have, Cv value you have, just little bit change. Okay, just take the value of dH. dH over dt is equals to dE upon dt plus dPV over dt. And from ideal gas equation, we know PV equals to nRT. And here n is equals to 1. So instead of PV, we can write RT. Okay, so it will be dH over dt is equals to dE over dt plus d RT upon T. See, we can write like dt upon dt. So dt upon dt, dt upon dt will be cancel out, we'll get the r. So it will be dH over dt is equals to dE over dt plus r. And we know that dH over dt is equals to Cp. So I will write Cp, which is equals to dE over dt. We have already done dE over dt, which is equals to Cv. So instead of that, we'll write Cv plus r. So we can write like Cp minus Cv equals to r. This is the relation between the Cp and the Cv. So this is quite important for the exam point of view. The question, most of the time the question repeated in the case of derivation is only this. So don't leave this. Okay, some processes also there. So we'll discuss that processes also. So if the process is called adiabatic. Okay, some process, let's discuss adiabatic. We have isochoric, we have isothermal. Let's don't take isothermal. Isochoric, isobaric, okay, and cyclic. Okay, these four. Adiabatic, in which the heat remains same. Isochoric, in which the volume remains same. Isobaric, in which the pressure remains same. So it's not a big deal. Cyclic process, in which you can if the reactant A is converting to B, B is converting to the C, and C again convert back into the A. So this is a sort of cyclic process. So this is again easy. Okay. Uh, uh, Delta H value. Remember, negative, delta H positive. This is exothermic. This is endothermic. So this is important. Just remember some relation you have to remember, that is delta H is equals to delta U plus delta N RT. Here delta H is change in enthalpy, Delta U is change in internal energy. Um, Delta N is equals to N product NP minus NR. Yani number of moles of product minus number of moles of reactant. Or you can R is here gas constant, T is equals to temperature. So sometimes the question can be asked like what is the relation between the delta U and delta H? So you can directly like that this is the relation delta H is equals to delta U plus delta Ng RT. Okay. So one more question is like that if question is enthalpy decreases is not the criterion of for spontaneity, and it will be why enthalpy decrease is not the criteria for the spontaneity. See, the change in enthalpy delta H is equals to just consider negative. It may be the condition, but not a necessary and sufficient condition for the spontaneous. So simply write like delta H do not depend upon the spontaneity criteria. We don't have any relation delta H in such a way. Okay. Mm, one more relation. I'm just okay. Yeah. One more relation, that is Gibbs free energy. This relation is also asked in the exams like delta G naught is equals to 2.303 RT log K. Okay, here delta G is Gibbs free energy, R is again gas constant, T is equals to temperature, K is equals to equilibrium constant. Okay, this is important, so just don't let. Gibbs energy, if someone asks like what is Gibbs energy, that is the amount, that is amount of energy which is available from the system, which is available from the system and which can be put to useful work at constant temperature and pressure. So this is the condition. At constant temperature and pressure, the amount of energy which is available by the system, okay, which can be converted for the which can be converted in a useful work. Okay. So in Gibbs free energy, there is a change like delta G, delta G, delta G. I'm writing. First case when delta G is negative. Second case when delta G is positive. Third case when delta G is 0. So these are the three conditions. If asked in the exam, like what happened when delta G is negative? So you can say the reaction will be spontaneous. Okay. If positive, it means the reaction will be non-spontaneous. If delta G is 0, it means the reaction will be at equilibrium. So these are important conditions you have to remember. Formula G is equals to H minus Ts. One formula, that is G is equals to H minus Ts, or you can say like delta G is equals to delta H minus T delta S. So this is the enthalpy change, or sorry, Gibbs free energy change. So these important questions of thermodynamics. Let's discuss some more questions from the equilibrium point of view. Question is like a law of chemical equilibrium. Law of chemical equilibrium, that is you can say like a ratio of product molar concentration to the product of the ratio of the product molar concentration of products. Here we have products. Okay, to the products of molar concentration of reactant. For example, A plus B is in equilibrium with C plus D. It means the K will be equals to molar concentration C into molar concentration D divided by molar concentration of A into molar concentration of B. So this is a law of chemical equilibrium. Okay. If someone say what is the equilibrium constant. So you can say the ratio of the product of molar concentration of product to the product of molar concentration of reactant, Kc. Okay. So if the definition is asked, you like this. If the definition of this equilibrium constant is asked, so you can define in your words in such a way. Okay. Um, what are the factors which influence the chemical equilibrium? Factors affecting chemical equilibrium. I'm just telling you the factors. You have to just go deep in this topic. Concentration of reactant and product. Equilibrium will disturb, you all know. Temperature of the reaction. Then pressure of reaction and inert gas addition. For more, you can again go for Lee-Chatelier principle. Okay. For more, you can go for the Lee-Chatelier principle. That is again quite important. Okay. Bronsted acid base we have discussed. Lewis acid base we have discussed. One more topic, that is ionic product of water. Ionic product of water. See, the product of the concentration of the H positive and OH negative. This is called ionic product. See, H2, if I break H2, it will dissociate into H positive and OH negative now. So if I write the K value, it will be molar concentration H positive into molar concentration of OH negative divided by the molar concentration of H2. And we'll write the H here. That will be H positive molar concentration into OH negative molar concentration. This is called ionic product of water. Okay. If someone asks like what is the ionic product of water at 25 degrees Celsius? This is equals to 1.008 into 10 to the power minus 14 mole square per liter square. This is the value. Just remember. Okay. What else? Like okay, some reasoning based question. Some reasoning based questions are also important. Uh, like all Lewis acids are not Bronsted acids. So we all know that Lewis acid are totally depend upon the electron pair acceptor, while Bronsted are totally depend upon the proton donor. So according to Lewis concept, acid, many of the acids are there which do not have proton. They are just accepting the electron. They do not have proton. So that's why we can consider as like that all the Lewis acids are not Bronsted acid. Okay. Some questions like again reasoning basis. Ice melts slowly at high altitude. Why? So simply like why it happens? What is the reason? Like ice and water are equilibrium only at particular temperature and pressure, but at high altitude but at high altitude temperature and pressure changes. You all know that at 0 degree we have two form, like in the like water form or the solid form is present of ice. Okay, so at higher altitude we know that there is a pressure change, there is a temperature change. So there is a change in which, like you can say that high altitude the pressure condition and the temperature condition changes. That's why the ice melts slowly there. Okay. One more question is on the basis of compare Q with K. K is equilibrium constant, Q is reaction quotient. Okay. If Q is equals to K, Q is less than K, Q is greater than K. This is the condition. Okay. So if the Q is equals to K, it means the reaction at equilibrium. Reaction is already at the equilibrium. Okay. If Q is less than K, it means the reaction proceeds in the equilibrium direction. If Q is more than K, it means reverse reaction of the above one. So just remember this. So these are the also some sort of questions. Now, if I talk about the numerical based problem, so once you have to revise the first all the relation, then you will be able to do the numericals. Okay, some past numericals you can easily do. Like for example, I'm doing like 1 mole of PCl5 is heated. Okay, in a closed vessel of 1 liter capacity at equilibrium, 0.4 mole of chlorine is found. Calculate equilibrium constant. The question is this only. So first you have to do the reaction. Like PCl5, it gives out PCl3 plus Cl2. First convert like at equilibrium what it get? 0.4 mole per liter. Okay. PCl3 is again 0.4 mole per liter and PCl5 was 0.6 mole per liter. So all the concentrations are given now. So what you will do? Kc is equals to PCl3 into Cl2 molar concentration divided by PCl5. Calculate it. It will be 0.4 into 0.4 divided by 0.6, that is equals to 0.16 divided by 0.6, which is approximately equals to 0 6 yeah, 0.2606. Okay, so just do such kind of numericals. So these kind of numericals are easy, but you have to remember the relation, then only you'll be able to do the questions. pH numericals are quite important. POH numericals are also important. Okay, so just go for it. And some one more time I'm telling you that solubility product numerical. Solubility product based numericals are most important topic. For example, like question I'm giving, like solubility product of ZrOH whole twice is 4.5 into 10 to the power minus 17 mole cube liter minus 3. What is solubility? Okay, so the reaction will be ZnOH whole twice, it will dissociate into Zn2 positive plus 2OH negative. So KSP solubility product will be equals to S into 4S square, that is equals to 4S3. Okay, which is given like now 4S3 is equals to 4.5 into 10 to the power minus 17. S3 will be equals to 4.5 into 10 to the power minus 17 divided by 4. That is equals to solubility, if you will remember, calculate it, 2.6 into 10 to the power minus 6. Just go for these kind of numericals. Okay, so that's all. And if more you can do, just revise all the topics which I have discussed here and all the main topics which we have dictated in the uh, normal classes. So these are quite important topics. Just go through these topics, and whatever the doubts you'll have, you can clear in the upcoming sessions. So just revise it. Thank you. This much is enough.